you are using a sample, right? So population, we use it when we do census, all right? And then we usually use descriptive statistics in our analysis. Whereas, okay, for sample, we do survey, opposite to that one is survey, and we also can use inferential statistic. And usually, the number of population we represent by using the symbol big N. All right. So N is actually the number of the population. Whereas for the sample, because it is a part of the population, so we use small n to represent the number of sample. So for example, N we have 1,000, right? So and our N here is 300, right? So that's what we call it as sampling theory. When we are taking some part of the population to be in our study, right? So is everybody okay? Do you understand this? Okay. So far we have learned the distribution. When we talk about the distribution of the population, so we have learned X is distributed with normal distribution, okay, with mu and sigma square, right? So in this case, the distribution for sample is slightly different because we have a smaller number of n, right? So then it refers to the n that we have taken from the population. So the distribution will be x, right? We call it x bar for the mean sample, right? Okay, and then n mean for the sample, sigma for the sample square, right? So that's the difference where this one, remember I told you before when we draw this normal curve, okay, the middle part should be the mean, right? Or X bar. Okay, mean, mu is actually the mean for the population. X bar is the mean for the sample, right? So that's why we take the mean sample here for the distribution. And if you can see, this one is, we have this additional notation. It is for to represent for the sample. But actually the process of doing it will be almost the same. Okay. So let's have a look. Okay, this is only the introduction. So let's have a look at all the terms that we are going to use in our sampling theory or in our chapter 5. Okay. So the first word, okay, based on your book, page 56, right? So we have population. So the population, as I told you before, is every single object or subject that we want to study, and we cannot we cannot miss even one, right? Whereas sample is actually a part of the population or the subset of a population. Right. Okay, and then sampling. Okay, I start from here first. Okay, this one based on page 56. Sampling is actually the process of taking a sample from a population. Okay, so that's what we call it as sampling. Right, so we have here taking from the population. So we take a sample from N. So we have N. So this process, we call it as sampling. Right? And then the next word that I would like to define for you all is actually on page 57. Sorry. Semua benda jatuh. Okay. On page 57, the word parameter. Okay. So what is actually parameter? Parameter is all the values that belong to a population. So anything, okay, that values related to population, we call it parameter. Okay, so for example, in our distribution just now, I said that for the population X, is distributed with normal distribution, mu and sigma square. So the parameter here is actually, one of them is mu and also sigma, right? The mean and also the variance for the population. But you need to know how to write the notation or the symbol correctly, okay? Because the symbol for population and sample will be different, right? And then, okay, for the statistics, is actually the values that we have for sample. So we have statistics here, right? So for example, for the distribution for the sample, we have mean for the sample, sigma for the sample square, right? So in our case, the statistics here is this one, right? So the mean for the sample is actually can be also be known as X bar, and sigma X bar, okay, sigma for the sample is also known as small s, right? So sigma here is capital S, so for the sample will be small s. So mu is actually the capital letter for M, right? So we use all the capital letters for the population and the small letters actually for the sample. Okay, is everybody understand? May you have any question, please let me know. Don't just keep quiet, okay? Assuming that you understand everything, but at the end of the day, you don't know, you don't understand what I have lectured today, right? So okay, so let's continue. So in terms of the word statistics, okay, hold on. Okay. This is if you want to write in your book, so you can copy this one down. I give you 2 minutes for you to copy this the definition of parameter and statistics. Okay. So this is the example of statistics, and this one is parameter. 2 minutes. Okay. Are you done? Okay, tell me if you done with this slide. Okay, thank you. Hui. Okay, thank you. All right. So today, starting from chapter 5, okay, actually chapter 5 onwards, actually we are now on inferential statistics, okay. So what does it mean by inferential statistics? Okay, inferential statistics is actually the process of making decision about some characteristics of a population based on our sample information. Why should it be based on sample? Because in our study, we are not using population. Instead, we use sample. So we need to derive, or we may need to make we need to make conclusion based on whatever we have studied on the sample, right? So the goal is actually to discover general pattern about a large group by studying a smaller group in the hopes that the results will generalize to the larger group. Okay. So for example, we study the son of apple or the daughter of the apple. Okay. And then we hope that whatever findings, okay, whatever results we get from here, it will describe the big apple, right? So the mother or the father of apple. So in this case, so if you study, for example, you find out in your sample that the apple is red, okay? So it means that we also can make conclusion that the large apple is also red, okay? So we cannot say that from our study, from the sample, we found out that the apple is red, but we conclude that the large apple is green. So it means that our inferential statistics is not good enough, okay, to be a part of our results of our study, right? So that's what we call it inferential statistics. Why don't we use population in our study, especially in our FYP? Because of the three constraints that we have in terms of the time, in terms of the cost, and also in terms of human resource. Okay. Right. So I just mentioned just now the word statistic, all right? Statistic which is belong to a sample, the values belong to sample. But when you read, especially an article, books or whatever, you will encounter, okay, you will see these three words, okay. All of them are actually statistics, okay. The first one, statistics with capital letter in front of it, all right. And then we have statistic and also statistics, all right. So statistic, the first one, this one is actually the field, bidang, right? Field of statistics. So it's actually a part of mathematics. So statistics is mathematics field, one of the mathematics fields, okay? And this one, statistics, all right, and statistics. So this one is actually, we can say, information that we get from a sample, okay? So statistic, this one, right, will be for singular if we have one information, and this one will be plural when we have a lot of information from the sample. So for example, we can say the statistic shows that, all right? So it means that maybe it refers to the mean, let's say the mean, all right? But if we say that we have found the statistics, okay, from our study, so people will understand it not just the mean, can be the variance, can be from the standard deviation, and so on. Any information, a lot of information that you obtain from your sample, right? So that's the difference between these three words, okay? Right. So the purpose of doing, okay, actually this inferential statistic, okay, the main purpose of it is actually to do estimation. Okay, we want to estimate. Okay, we want to estimate what's going to happen, in the large group, because we only study the small group and we want to estimate the large group. So the analogy that I used just now, a small apple, we want to estimate what is actually the characteristic of the big apple, right? So that's what we call it as estimation. Okay. But the verb or the process of doing the estimation, we call it as estimate, to estimate, right? So this is the procedures. So hopefully, during our face-to-face class, we can also do this one, okay? Based on that 50 list that you have collected somewhere, all right? So the first thing that we need to do in order to do this estimation, we must have a sample, because remember, we are doing inferential statistics, okay? So we need a sample, right? And then we need to collect requirement information from the members of sample. So we need to get statistics, right? A lot of information. So for example, we need to find what is actually the mean of the sample, what is actually the standard deviation and the variance, the n, and so on, right? So then we need to calculate the values of the sample statistics. So we need to calculate the mean, all this, okay, based on, we can use the formula, or we can even use SPSS. And then we can assign the values to the corresponding population parameter. Okay, usually, so this is what happened. The mean of the sample must be always similar to, or same or equal to, the value of mu. Why did I say that? Remember when we draw this normal curve, all right? The center will always the mean, right? So the mean should be the same. Only the difference is the distribution, because here we have less n. For the population, we have bigger n, right? So when I say the distribution, the shape is slightly, or the peak slightly different, right? So that's what you need to know. The first thing, when we do estimation, we hope that the value of the mean for the sample should be equal to the value of mean of the population. So, for example, I study the age of participants in a certain webinar, right? So I have the participant, the total of the participant about 500 people, but I just want to do a survey, so I select only 100 people. So and we have 500, okay, but I would like to study only for 100 participants. So what happened? I start collect, their information, for example, their age, right? So then I need to calculate the mean for the mean age for the participant, the 100 participants. So let's say the mean age, I found out that 21.7 years old, right? So I hope that actually this mean, all right, this mean actually equal, or it can tell exactly the same age of the whole population. So we are hoping that this one, the mean will be 21.7 at the middle. So if, let's say, if I ask someone else, okay, to do the same process, but this time that person need to calculate the mean of the whole participants. So let's say that person found out that the mean is actually 22 years old. Okay, so I can conclude that the mean that I found from my sample actually can, can represent the actual mean, the age mean of the whole population, because 21.7 is very close to 22 years old. So it means that my estimation is good, right? So that's what we want to do. So, and then I've told you in terms of what estimation is, and then also what is estimate, to estimate, all right? And then the next word that I would like to introduce to you all is estimator. Okay, so estimator is a rule for calculating an estimate of a given quantity based on observed data. Or estimator, we can also actually, estimator is actually same as statistics, right? So we can say either one. So the estimator statistic actually mean the same, or estimators statistics, all right? So the same thing. Right, this is the type of distribution. So we have learned the type of distribution from the population. Remember, this one is xn mu sigma square, right? So the mean will be mu. Okay, the center will be mu. But when we take only a part, okay, this one with n, right? But when we take a part or just a sample from this population, we are going to have the same shape of the distribution, but only, it has slightly different, okay, like this, because this time we only take this one should be X bar because we only take a few from the population. So this is the difference, okay? The difference. So this is small n when we take a sample, and then we have a larger curve, okay, when we are to represent the whole population distribution. Okay. So I would like you to draw this one, okay, on page 58. Okay, is everybody okay? Yeah. All right, good. Thank you, Anong. All right, so before I forget, all right, so there's one table that you need to fill in on page 57. Okay, so statistic or estimator, right? So, and then I would like you to, hold on. Okay, so we have statistics, okay, estimator, and then we have parameter. So I would like you to fill this one in first, okay, before we proceed to the next page, right? So the first thing we actually in our inferential statistic, our job is to do estimation, right? So the first estimation that we need based on this one, just write this one sample from the sample, and this one for our population. So we are going to do this estimation, okay, from the sample to population. So the first one will be our mean, our X bar, okay. So we need to estimate for the population. So we hope that the value should be same as mu, okay. And then, okay, only this one, all right. So for the sigma, uh, sigma is known as estimator or statistics, but sorry, I got it wrong. So it should be small s, and this one is sigma. Okay, but the value of s shouldn't be equal can with the sigma, because remember the shape of the distribution is slightly different. But the only thing that should be the same is this one, these two numbers, right? And then 3, if we have standard deviation, variance, so this one is sigma squared. And then if we have small n, so this one we use notation of capital N for the number of population, right? So I want you to fill that one in, okay? There are some more actually, but not in our syllabus. For example, P, this one is pi. This one is actually for proportion. So it's not in your syllabus, right? So what I would like to say, we use small letters, okay, for to represent for the sample, and capital letters for population, right? Okay, let's continue with sampling errors. Okay, what does it mean by sampling errors? Sampling errors occur when you are making mistakes or error while taking your while doing your sampling process. Okay, So while taking your let's say you have, okay, so for example, okay, let me, okay. So for example, I put this way, okay, when you are taking sample, right, so you do the sampling process in order to get the sample. So this is your population, right? So what happen, let's say your n here is 1,000, and then you take sample only 10, right? Do you think that 10 people can represent 1,000 people? Can or not? Anyone? Hasha. Hasha, is it? Yeah. Ah. Boleh tak Hasha?
What do
10 orang that represent 1,000 people. Do you think it's enough?
No, I think
No. Okay. So let's say there's a one person claim that UTM students are lazy, right? So bila kita dengar dia dia punya dakwaan, the claim that UTM students are lazy, you know that you are not lazy. You've been working so hard in UTM. And then when we ask that person, all right, so we know that UTM students has thousands of students, and then we ask that person, how many student involved in your survey, how many sample did you take? And that person answer, oh, I took 10 students to represent the whole UTM student. Is it fair or not? It Yeah, sure, it's not fair at all right, because maybe it happened that when that person selected 10 people for the sample, might be those who are lazy people. But actually, thousands of UTM students are actually very hardworking and very diligent students. Okay? So it's not fair. So this is what we call it as sampling errors. So the number of sample cannot represent the actual number of population. So you need to increase the number of n, right? And then the next one, okay, the sampling errors also can happen like this, okay? I would like to study in terms of, like CGPA, student CGPA. Right. So what I did, I supposed to take, remember, students based on this normal curve. Only a few students who are CGPA less as low CGPA, and we know that most of the students have a CGPA, for example, 2 until 3, for example, right? And only a few have CGPA above 3. This one below 2. Right. So this is what they're supposed to take for their sample. But then what happened in their study, they only take, all those people who are not good, right? So with CGPA less than 2, dominate the sample, this person sample, for example. So what happened? This one cannot represent the whole population, the true population of UTM students, for example. So it means that the sampling errors will occur, okay? So the results that they will get, for sure, it cannot be accepted, it won't be valid, all right? So this is what we call it as sampling errors, some of the sampling errors, where the errors come from the sampling process. Understand? Okay, tak? Right, the next one is non-sampling errors. Okay, non-sampling errors. Okay, non-sampling errors mean errors that occur not because of the sampling process but come from the researcher himself. So, for example, typo, in terms of typo, okay, instead of typing 50, uh, that they enter the data 15, all right? So this is only the typo error that comes from during the data entry, all right? So this one is called as non-sampling errors. Also, some people mungkin what happened, they type, okay, let's say 21.77, but they write it as 31.77, right? Again, this is typing errors, okay? So those can be considered as non-sampling errors, right? So we already talked this one. And then I would like to go to the central limit theorem. Okay, this one is actually on page, this one. Okay, page 60. Right. A very popular, or I should say that the foundation of taking the sampling theory is actually based on this theorem, which is called as the central limit theorem. Okay, so this central limit theorem, I know when you read this one, you won't really understand what does it mean. Okay, so but actually, it says that in order for you, okay, to have normal distribution for your data, your sample size should be at least 30, right? So if you have less than 30, so this is called as small data, right? But you need to get, at least 30 in order to make your data normal, right? Has normal distribution. So that's the reason in FYP, we require students to have 50 data, right? To make sure that they will have, very good results and reliable results at the end of the study, right? So there are a few methods for making inference. First one, estimation. So we are going to learn how to do this estimation. Remember, we just mentioned the process, take a sample, and then calculate, get the information, calculate the mean, and so on. That one we call it as estimation. But there's another one which is very popular, okay, very popular in data analysis, where we use hypothesis testing approach. Okay, so this one usually in SPSS. So we use this hypothesis testing approach. And estimation usually we use when we want to calculate manually, right? Okay, so let do some examples. Okay, before that, right? So I would like you to write this one. Okay, this one in the box on page 62. Write it as big as you can, as large as you can. Don't write it very small, and at the end you don't even understand what you have written. Okay, people with small handwriting is actually shows that person's personality. Less confident, and very what should I call? Um, Introvert. Okay, introvert. Yeah. So if those people who have large handwriting, usually these people very confident, have highly confident in himself or herself, and also extrovert people. All right. So remember, personality can be changed. So you need to change bad personality. Why, Esan, you don't trust me? Or you mengantuk ke apa, Esan? Okay. Right. Actually, a part of my apa, a part of my study before, actually I did on psychology. So I took a few psychology classes. So that's the reason I learned something from those classes. Okay, so you done? All right. So this is what we call it as mean sampling distribution. Okay, mean sampling. So it means the sample for the sample distribution. Why is it called mean? All right. So I will explain in a few minutes. Okay, but so the X bar mean sampling. That's the reason we call it as mean for the sample, right? Because it must be at the center when we are using the sample distribution. So, and then N mean for the sample, right? So actually before we have just X and mu and sigma square, right? So actually the same thing, but it's just that we want to differentiate between population and sample. So that's the reason we add X bar here in order to tell us this one is actually for the sample distribution. So the mean, okay, the mean for the sample is actually known as X bar, and then the value should be same as the mu, right? The mu for the population, right? So you must understand, you can write this one as mean X bar or mean sample, or you can write X bar. It the same thing, right? So and then the sigma or S, okay, I call it S, can be called S or sigma for the standard deviation for the sample is actually equal to sigma from the population, eh, and divide by the number of sample that we have taken from the population. Okay, so that's what it means. Right, so let's do some example. Example number one, right, on page 62. So we have the first one, 36, all right, and then mu 10 sigma square is equal to 9. So how to do this one? Okay, I'll do the first one for you, right? So we have n is equal to 36, and then mu is equal to 10, and then our sigma square is equal to 9, right? So the first step that you need to do, you need to write the population distribution first, right? So it will be easy for you to see, right? The changes and so on. So we have x and mu, right? The mean is 10, right? Remember, we need the value of sigma, not the variance. Okay, so sigma will be equal to 3, which is the square root of 9. So you need to write 9 square like this. Sorry, 3 square. Understand? Right. So in order, then because we have another information, okay, we have n, so it means that we have taken some sample from the population, then we need to find the distribution for the mean sampling, all right? So we have, remember, mean for the population and mean for the sample will be same as mean for the population. So it will be this one. So the mu should be this, the mean for the sample will be the same, 10, right? So it doesn't make any changes at all. So it remain the same number. But the problem is the changes will be in here, right? So we need to calculate for the standard deviation for the sample is actually equal to sigma divided by n. So the sigma is 3 divided by the square root of 36. So we have 3 over 6, which is 0.5, right? So here, or I should do this way lah, step by step. Okay, x bar n mean for the sample, sigma for the sample square, right? So we have x bar n. So this one 10 remain the same. So this one we got it from here 0.5 square, right? So that will be the answer for part A. Right. So once you finish, I would like you to continue with part B and also part C. Okay, you can check your answer on page 68, right? Okay, so we don't have much time. Okay, let me proceed to example number two. You can finish your example one. If you haven't finished it yet, you can finish it later. Right, so let's go to example number two. All right, so example number two, this one is very important because your test will include all this kind of question, right? So the following data give the test scores of 5 students in a prerequisite statistic class. Find the sampling distribution of X bar. So we are asked to find the distribution. At the end, we need to find what is actually the distribution of the sampling distribution, right? This one. Okay. So in order, this one is slightly different. Before we are already given the value of mean and also the standard deviation. So, but this time we need to find it out on by ourselves. All right. So how can we find out the mean, the value of mean, okay, and also the value of S? How can we find this one out? By using calculator. Remember in chapter 3, we learned how to actually calculate the mean and also the standard deviation from our calculator. So therefore, you need to use calculator, enter the data. So for example, 70 and plus. Sorry. Sekejap ya. Okay, 70 and plus, 78 and plus, 80 and plus, 85 and plus. Um, page 42, right? Remember, if you cannot remember, go to page 42 and then just press shift 1, all right? So, and then shift 2, right? And then get 1 for the mean and also the standard deviation, shift to option 3, okay? So, can you please do it now and give me the answer? Zulaika, can you give me the value of mean? And then Puyi, can you give me the answer for S?
81.6 for mean.
Okay, thank you, Zulaika. Puyi, did you get for S?
Doctor.
Sorry?
I won't get it.
Okay, just try to get it. Okay, don't worry, I'll wait for you.
9.24.
Okay, so how about the rest? Are this answer okay or not? Can be accepted or not? Boleh diterima atau tidak? Anyone? Ziling, what do you think? Betul ke dia
Yes,
this
doctor.
answer? Okay, so we can accept. Okay, then from this actually you can write the first distribution. Okay, so mean and sigma square, right? So it means xn 81.6 and then 9.24 square, right? So this is the first step, right? So in order to get, for the mean sampling distribution and mean for the sample, sigma for the sample square, right? So this is what happened, right? So this number will remain the same. We don't have to change it. So x bar and so 81.6, right? And then only this one we need to recalculate because the value change, okay? So and then sigma x bar is equal to whatever, okay? Sigma divided by square root of n. Remember, sigma x bar is not this one. You cannot take simply from here, but you need to use this formula, right? And then, so this one is 9.24, okay, divided by square root of, how many n do we have? What is our n? Berapa n? 5. Okay, thank you, Tika. Okay, so our n is 5. So I would like someone to calculate this one for me. Okay, siapa saya nak Idora, can you calculate this one, Idora, for me? What is the answer?
4.132.
4.132, okay? So let's say we just take one decimal point, so 4.1 square, right? Right, because just want to make it similar to the value of mean. So this is your mean sampling distribution, right? So that will be the answer for example number 2. Right, I think that's the end of our chapter 5. It's very simple, just to introduce the mean sampling distribution to you all, how to calculate the new distribution, okay, based on what we have learned in chapter 4, right? So in our chapter 6 and so on, so we are going to repeat this chapter, the information, the knowledge that we have got from chapter 4 and 5 again and again and again for the next or the future chapters. All right. So let me get you your okay. Okay, we start with section 2 first. Okay, so I'll see you again, people. I really hate this that we need to cancel the whole class next week for the Hari Raya. So I will meet you again on Sunday, which will be on the 8th, right? 8 May. So I wish you a happy holiday to every one of you, and for all the Muslims, Selamat Hari Raya. Okay, maaf zahir dan batin. So I really hope that you will enjoy your Hari Raya after 2 years. We didn't we couldn't celebrate the Hari Raya properly. So but please make sure you stay safe, jaga your SOP, don't just simply go here and there without wearing mask. Okay, but just take care, and I hope to see you again after Hari Raya. Okay, everyone, enjoy your Raya.
Doctor, I want to ask
Yeah, sure.
for the
Sekejap ya.
group assignment.
Yes, sekejap ya, Satria. Okay, hold on.
Yes, for the list of samples, it is consists of what? It is
Oh,
consists of what, Doctor?
list of sample. Which one, Satria? Can you? Sebab saya pun dah tak ingat yang mana satu ya.
The template that you give
Uh-huh.
us on the fourth section.
Okay.
Yeah, there is a list of samples, but we are confused about what is consists of.
Okay, sekejap ya. Let
Yeah.
me settle this one first.
It's 4.0, Doctor. Population and sample, then it's like 4.5 list of sample.
Oh, okay. Is regarding your sample. So let's see. Sekejap eh. Okay, section 1 is ready now. Right. So you need to give, example, who actually in your pilot study. You have done your pilot study, right? For 10 people?
Yes, Doctor.
Okay. So those 10 people, you need to list them down. Okay, who are they? For example, if you get their information. So those 10 people will be your sample. Your population, who are they? So for example, you are doing a majority of you are doing study in UTM, okay, UTM students. So you need to inform how many students. Let's say if you are doing the faculty of engineering, so how many students in faculty of engineering? So your big N is how many? And then N, your small N will be 10, right? Because you are doing your pilot study. So who are they? These 10 students. I really hope that you can have a list of them.
Doctor, then what's the difference between 4.4 and 4.5 sample versus list of sample?
Yeah, sama lah benda tu. Sample, you need to tell, like 10 people from where?
Right. Then list of
Okay,
samples
so
like
you
the
need to
actual.
describe. You need to describe who actually your population is, who your sample is, and then you need to give the list of them.
Got it. Okay.
Okay, so
Doctor,
for example, let's say you know their IC number, you know their faculty, their age, that kind of information.
okay. Doctor, one more question. Can we exceed more than 10 pages? Because even right now, my group's
Yeah.
like 15 pages.
Somebody already asked in the previous lecture, Hasif. So
But then
allow.
due to like 5 to 10, they're not.
Somebody, I think I cannot remember. One of you already asked. So I allow, but not more than 20.
Okay, great.
Okay.
Right, thank you,
So
Doctor.
it means that the content should be not more than 10. Maybe you have like, attachment or whatever. It may consist of more than 10. Yeah.
Okay, all right, great.
I can
Thank you, Doctor.
understand. All right, sure. Okay, anyone else? Any other questions? Okay, once you already scan your attendance, you may leave our last session for today. All right, thank you very much.
May I confirm with you that minimum.
Okay, who's that? Sorry.